Hello, my name is Daniel Farland, and I'm responsible for Network Solutions Marketing in the Transportation vertical for Alcatel-Lucent Enterprise. I'll provide an overview of the cybersecurity threats in transportation and the multifaceted approach that Alcatel-Lucent Enterprise uses to minimize these threats. ALE focuses on four major segments of transportation: rail, road, air, and sea. Each of these segments are very different in terms of customer needs and solutions. In addition, each transportation segment is divided into subsegments, each with their own unique requirements. I'll be discussing ALE's approach to securing these segments and subsegments as an overall strategy. This strategy encompasses three major pillars: passenger experience, operational efficiency, and last but not least, safety and security. How secure are my network devices, Wi-Fi, internet access, and communication systems in transportation? Well, they're all vulnerable and have the same issues with access control, single point of entry, etc. There's a high impact potential with hundreds of thousands or more IoT devices on the network, and any compromised device can be a gateway to the network. So, what additional risks do you need to consider? Well, attacks on non-critical networks such as entertainment systems or passenger Wi-Fi may seem no more than an inconvenience at the time, but they can be a path to much greater access for the hacker. Security vulnerabilities exist in the most unlikely places throughout all transport networks, and since these networks are by definition on the move and distributed, they can be much harder to protect. According to Razor Secure, a transport cyber defense expert, rail, aviation, and car manufacturers and operators can expect more and more attacks of their distributed IT assets and networks in the coming year. These technologies are becoming common elements in transportation in order to increase capacity, safety, and comfort for travelers and working personnel. IoT devices enable a diverse set of applications, but they're all connected by a common thread: mobility, IoT, and Ethernet. Today, on roadways you find digital traffic and pedestrian signaling, video surveillance, digital road information displays, variable and active speed limit signs, and increasingly Wi-Fi on buses, at stations, and depots. In rail systems, digital signs and ticketing, as well as Wi-Fi at train stations and on rail cars, are common. Airports provide Wi-Fi for travelers and visitors, and increasingly are deploying location-based services for wayfinding, while port authorities are using outdoor Wi-Fi and asset tracking methods to simplify logistics and management of freight on the docks. All of these are increasingly being connected via Ethernet, both wired or wireless, to an IP network. And newer IoT devices such as traffic volume and speed sensors, active warning signs, and positive automatic train control are increasingly being deployed to improve passenger and traveler safety. These devices and sensors are found along roadsides and trackside, and some are embedded in roadways and next to rail tracks. There needs to be a secure method to connect these devices and sensors to a network infrastructure so they can be managed, monitored, and cost-effectively maintained without increasing the likelihood that they can be breached by a cyber attack. With the increased use of mobile devices, BYOD, and IoT, the need for security is becoming more relevant. Cyber attacks are increasing in volume and in the cost to recover from these attacks. Recently, the San Francisco Municipal Transportation Agency was attacked for ransomware, which took more than 2,100 ticketing machines, workstations, and computers out of order. The Transportation Authority was able to recover their network, fortunately without having to pay the ransom of $73,000, but their estimated loss in fares was more than $500,000 per day over the U.S. Thanksgiving weekend, so a significant loss in revenue and a damaged image and brand. Security in voice communications is also an issue, as it all started here, telecom fraud. This represents a significant cost loss for companies. The main driver in telecom fraud is to make fast money through a communication system calling a toll service. In 2015, the estimated cost loss was $7.4 billion for PBX hacking, so it is the #1 threat for communication systems. But communication systems also became digital, so these systems are now more exposed to cybercrime than ever before and have become more vulnerable. There are two main goals in these types of cyber attacks: information theft that can impact the intellectual property, strategy, business, and competition, and loss of communication services that can impact the operation, continuity, and passenger safety. Cybercrime not only impacts your costs, it can also negatively impact your image and brand, affecting how you are viewed related to passenger experience, operations, and safety and security. As we've seen before with networking fraud, the cost of prevention is lower than the cost to repair and rebuild your brand. What about network security? Can cyber attacks happen in transportation network infrastructures? You bet they can. There are a variety of network cyber attacks that can take place, including distributed denial of service attacks, worms, undocumented backdoors, viruses, etc., and the list goes on. Recently, there was a distributed denial of service attack which took down major websites in the United States for hours. Now, imagine if a digital speed limit or highway traffic sign or train signaling system was compromised. How could that impact traveler and passenger safety? What about the impact to business if you can't get on the ticketing system to book your tickets? Then you have undocumented backdoors. A manufacturer may decide to design a backdoor to gain access to a device operating system in order to provide maintenance or other software modifications or tests. It can also provide unauthorized entry into a switch, which can be exploited by hackers. A couple of major vendors were found to have these backdoors in their products. Not counting the ransom from ransomware attacks or the damage to reputation of a brand where customer loyalty can suffer after a hacking event, it can cost tens or hundreds of thousands of dollars to recover from a cyber attack. Preventing a cyber attack is much less expensive than recovering from an attack. So, where do you find a network infrastructure solution for transportation that is made up of products that are IoT ready, secure, easy to deploy, maintain, and manage? Well, let me tell you more. Alcatel-Lucent Enterprise uses a comprehensive layered approach to provide network security in order to minimize risks from cyber attacks. We secure, authenticate, and authorize access for users and devices. Next, we can look at the applications running in the network and use analytics to decide what actions to take, if any. We can monitor the network integrity to ensure it is running at optimal performance, and we use IoT Containment to provide secure access and separation of the various private network containers. Together, they make up the key elements for our network security strategy. ALE's network security technologies are built into every switch in order to protect against cyber attacks. We start with user and device authentication, which only allows authorized users and devices to be connected to the network. Next, we use Access Guardian, which is a built-in feature for our network switches, enabling you to select the type of authentication method and security to use. We follow that with our Quarantine Manager, which uses intrusion detection and automatic quarantine functions to safely prevent users and devices from connecting to the network. We then add Code Guardian to further protect the operating system software in each network switch. Together, they make up the key elements of our network security strategy. Along with the benefits of using a single network infrastructure supporting a private network for every department, comes the benefit to use a single network management system. This enables the user and device access and management, backbone network and data center visibility and metrics, all on a single platform. App visibility shows which applications are running on your network and which ones are using the most bandwidth. Predictive and traffic analysis enables you to estimate future network usage and detect unusual traffic patterns. And network policies provides the means to set up user and device policies. This network management system helps you understand your environment and get alerted to any conditions that may change outside of your defined boundaries. Visibility and analytics help you protect your network and make better decisions. Next, we enhance our network security at the operating system software level using a three-layered approach to software assurance called CodeGuardian. The OmniSwitch product family adopts multiple operating system built-in techniques to mitigate or prevent attacks, including flood, control gates, task CPU usage monitor, and control. In order to further secure the operating system, or AOS, running on the switches and routers, the OmniSwitch has adopted the LGS CodeGuardian technology. This technology mitigates larger enterprise risks at the source, including software viruses and ransomware, enabling an enhanced security profile through independent verification and validation of OmniSwitch source code, software diversification of OmniSwitch object code to prevent exploitation, and secure delivery of OmniSwitch software to customers. Let's take a look at IoT containment. IoT containment is used to separate and secure specific devices or a group of devices from others in the network. For example, signaling systems, video surveillance, communications, and back office. IoT containment enables IoT adoption securely and efficiently. This is a metro rail example. If we take a look at the different elements that are part of this network, you'll see that security cameras, intrusion detection, exit signs, etc. may apply across various areas of the rail business. We have ticketing systems, emergency phone, digital signage, toll systems. When you combine them all, you want to make sure that the access to one part of the network does not go into another part of the network. So for example, you have passengers and travelers going to the train station talking to agents. They need access to a particular ticketing system. Then you have first responders and nurses, doctors, that are available in case of emergency or security threats. They typically use another part of a network. Then you have administration, which has their part of the network, and usually the train signaling system has its own network. So how do we secure these from other areas of the network? We set up containers. In this case, we'll set up a signaling container for the train signaling to the servers. We set up another container for traveler services. A third for security. So for example, if you were to set up a video camera at the security container, you would set up a security profile for that type of camera, so whenever it's connected, the system would automatically detect it and accept it into the network, authorize it, if you will. As well, you can monitor the type of applications that are running through your network. So if you set up your camera for SIP traffic only, and you notice that there are attempts of other traffic flowing through it, or a lot of bandwidth running through that particular camera, that may be an attempted denial of service attack or a cyber hacker, which will enable you to take action such as shutting that camera down. And this is how IoT containment can protect your network and set it up as a single network infrastructure using virtual containers to secure the rest of your network. With all those devices and sensors providing information, You need a method of capturing, analyzing, and understanding what's going on within the network and at the edge. Smart analytics is the answer. Our OmniVista 2500 network management system with smart analytics provides a wide range of in-depth network-wide information to assist IT personnel in understanding the usage of the network. It helps fine-tune the network to protect and enhance the user experience, and in addition, the unique integrated predictive analysis engine provides network trend analysis to support proactive versus reactive capacity planning. Smart Analytics has a network-wide view across wired and wireless devices, which makes it possible to identify new and evolving network applications from any device. The OmniVista 2500 can also download and install updated application signatures to identify new and evolving network applications, further simplifying management and reducing operational expenses. IT now has a comprehensive dashboard and reporting tool to understand the performance and usage of the applications, switches, and users with detailed troubleshooting information, along with the ability to enforce quality of service policies across the entire network to deliver a high-quality application experience. Smart analytics means application visibility and predictability for IT. Now, if we look at communication systems, there are a variety of ways that they can be compromised. One is voice communications fraud. There are three main risk factors around voice communications fraud: aging systems, outdated security policies, and careless configuration. These vulnerabilities are becoming prime targets for cyber hackers, and any of these can lead to a compromised system. Another way a communication system can be compromised is through a denial of service attack. This can be initiated via a variety of sources: unauthenticated LAN devices, no LAN security policy, or lack of regular security monitoring. All of these are also becoming a target for cyber hackers to shut down businesses, demand ransomware, etc. And finally, a compromised communication system can lead to information theft. This may result from unencrypted voice-over IP communications, an unsecure LAN policy, or important information shared over the phone. This is also becoming a target for cyber hackers who use the information or sell it for various nefarious reasons like credit card fraud, identity fraud, and so on. So how can we help avoid these communication system vulnerabilities? By implementing a cybersecurity strategy based on three main pillars. First, with built-in security systems, providing technology that monitors evolving threats, software assurance to allow the customer to have the latest version of software, aging password policies, built-in security expertise, system protection against denial of service, IEEE 802.1x compliant for IP devices, no backdoors between TDM and IP traffic. Second, confidentiality and encryption, providing end-to-end encryption for voice and signaling for internal and external communications over a SIP trunk, integrity of messages, binary signature of configuration files, secure management session over SSH, TLS. And finally, with best practices. This one is really key in the cybersecurity process because it will reinforce the two previous aspects. Here are some examples of best practices. You have voice and data VLAN partitioning, separation of operation and users, call barring implementation for the system and voicemail, external authentication via radius server, and protection of the voice network from the internet. Cybersecurity is a process and requires a layered approach, and these are some of the ideas to help prevent cyber attacks. This is an example of what a communication system network would look like with security and encryption implemented to reduce the risk of a successful cyber attack. So to wrap up, ALE solutions provide three key benefits for the transportation industry. We provide increased value for transportation authorities by providing solutions that enable transportation authorities to deploy innovative services quickly and securely, maximizing their long-term investments. We also improve safety and security by helping the transportation industry move to IP, IoT, and real-time applications. This provides transportation authorities with more options in delivering safety and security for travelers, personnel, and vehicles such as cars, buses, passenger trains, etc. And ALE helps transportation authorities deliver unique traveler services by providing solutions that enable real-time, end-user and traveler services on roadways, railways, at train and bus stations, airports, or on shipping docks. This results in enhanced services for passengers and improved customer service for transportation authorities. Thank you for listening.